Hi everybody! In today's video, I would like to show you a possible application of Titan for flow monitoring. The following problem is a typical operational area of the company Hunch, an associated partner of the Titan project. In the production industry, the use of machines are very common. However, through constantly running, the machines become very hot and make the air around them also hot. When the temperature rises to a certain level, it could start damaging the machines. Since the machines are not so cheap, air conditioners are used to keep the surroundings at a constantly cool temperature. However, if an air conditioner were to stop working, or get blocked without any alert, this could be very costly for the company. Modern air conditioners have an interface where one can read the operational status. Along with the operational status of the air conditioner, it is also important to measure the flow rate. The company Hunch specializes in manufacturing flow rate sensors. Their sensors can precisely measure the flow rate of any gas or liquid. We're going to use a Hunch sensor to monitor the flow rate. We have two values that we can monitor. But why clear a problem when we can cause one? In collaboration with the company Hunch, we have managed to build a demonstrator that can mirror for us exactly the scenario we just showed. Here's the thing that does it all. It operates as good as it looks. At the bottom, it has a fan that sends air upwards in two different power levels. At the same time, here are the sensors built in from where they can measure the air. So we're going to introduce a little problem in the demonstrator using a piece of paper so we can break the flow of the air. Now only one step is missing. We have the data, but we need to build the logic. And now comes Titan in the picture. Welcome to the user interface of Titan. I will only show you the building of a flow so that we can monitor the demonstrator. For the first step, we log in, of course. What we see here first is a list of all our flows. I've already prepared a flow, which we will see in detail now. To do that, I'm going to click on it. The flow needs to deal with the following problems. As the first point, the sensor's data must be entered in the system. Second, the data needs to be saved in a database. And finally, the data needs to be monitored, and in case of an error, we must be notified. And now we're going to try and solve all these three problems. We can see a lot of bricks with colorful images. And for this flow to work, we're missing two key bricks. Let's go ahead and add them. To do that, we can click on the brick package here on the left and search for the needed bricks. We drag the Arduino Uno and the Hunch TA10 bricks in the flow and drop them. To understand the flow, we need to first understand the functionalities of each brick. The Hunch TA10 receives the measured data from the sensor. The Arduino Uno brick receives the measured data from the fan. They both send the received data simply forward. The two InfluxDB parser bricks receive data from their corresponding sensors to create a data object to ultimately have it saved in the database. The InfluxDB writer receives the freshly created data objects and saves it in a database. The flow check brick compares the data coming in from the fan and the data coming in from the sensor. In case they do not match, it will send a warning in the form of a message to the Twilio writer brick. The Twilio writer brick sends a message in the form of an SMS to a number of your choice. So typically, bricks need to be configured. But the bricks that are already in the flow, I've already configured them. You can thank me later. Let's configure the Arduino Uno and the Hunch TA10 bricks together. Both bricks need an IP address under which they are reachable inside a network. We can enter the IP address here on the right side in the property pane for the Hunch TA10 brick. You can see all the parameters of the currently clicked brick here. Let's go ahead and configure the Hunch TA10 brick. And then let's do it for the Arduino Uno brick as well. All the bricks need to be connected to form a flow. We can do that with dragging and dropping the ports together. And with that, pops up a dialog window. This dialog is called the port mapping dialog. To learn in detail how this dialog works, you can find the video in the info card. But to just give a little summary, on the left side, we have the data of the first brick as output. On the right side, we have the data of the second brick as input. For the bricks to work properly with each other, we need to connect the data with each other. For example, like this. So now that the flow is complete, we're ready for some action. We can start the flow with the play button here. The flow will start now, and with that the demonstrator will be started too. In order to show how everything is working, we've set up a monitoring dashboard. I believe everything seems to be working pretty darn good. But now we need to create a disturbance. For that, I'll go ahead and put a piece of paper between the fan and the sensor in real time. And as I did that, you can immediately see a change in the graph. I also receive an SMS that something seems to be wrong with the fan. The flow rate also seems to not be showing proper values. That was just one example for monitoring a fan in a company. Titan may be a small step for the company, however, a big step towards digitalization.